All right, so let's try this again. Okay, on page 107 and 109, we're going to talk about cross sections and revolutions, and then on page 109, we're going to talk about radians, degrees, and sectors of a circle. All right. Page 107. Our objective is to determine the cross section of a solid and to identify the solid created when a two-dimensional shape is revolved around an axis. So what is a cross section? A cross section is a slice of a solid. It's a 2D shape created by the intersection of a plane and a solid. Okay, so I'm going to start with a cylinder. Well, yeah, I'll start with a cylinder. Okay, so that's my cylinder. If I were to do the cross section using the horizontal plane, so that means that I'd have a plane kind of coming through like this. Okay, if you can imagine a little plane passing through that. Okay, that cross section, the place where they overlap, would be a circle. A vertical plane, okay, that would be perpendicular to the base. So perpendicular to the base, this top circle would be a base, okay? So if I could visualize that, okay, it would kind of come through the top and down the side, and I'd have this shape right through here. And that would be a rectangle. If I can make it look like a rectangle, that would be most helpful. Okay. If I could think of the horizontal plane as being parallel to the base, okay, I kind of go through this shaded in part, and you would see that circle. Okay. So if I did one for a cone, okay, I could do a horizontal plane, again, that's parallel to the base. So if I kind of put a piece of paper horizontally through, that would again make a little circle in there. I did a vertical plane, let's say this one's perpendicular to the base and through the tip. Okay, kind of go through right here. And make a triangle. So if I kind of slid a paper through that cone, through the tip, it'd make a triangle. Now I could do another vertical plane. Perpendicular to the base. But not through the tip. I'd get a different section. It'd look a little bit different. So let's say I had another cone. Okay, and let's say I were to put a piece of paper through a different part of it. If I put it through right here, it wouldn't be a triangle. It would be kind of like a half moon type shape, or rainbow type shape. Okay. Another shape that we might see that would be a little bit confusing is a pyramid. I always draw my pyramids badly. Give me a minute here to make it look pretty good. Okay. If I did a plane that was parallel to the base, well, the inside, that shape would just be the same shape as the base. It would just be like a square or a rectangle. Okay, now if I did a vertical plane, and remember there's two vertical planes. I'm running out of room here. One that's perpendicular to the base, I can have through the tip. So let's say I had another pyramid. Okay, and my plane now went through the tip. Help if I made a plane. I would see a triangle as the cross section, but not through the tip. Okay, let's say it went through like down here. Well, that would be a totally different shape.
Please call the main office.
It would be kind of a trapezoidal shape. Okay? So if it goes through the tip, it makes a different shape, usually a triangle. If it doesn't go through the tip, it kind of either makes like a little rounded rainbow type shape or a trapezoid type shape.
Steve Micah, if you're in the building, could you please call or come to A100? Steve Micah, if you're in the building, could you please call or come to A100? Thank you.
Okay. Now, the other thing we can do is we can take a two-dimensional object and make it into a three-dimensional object by revolving it around one of its axes. So if I took a rectangle and revolved it around this axis, what would happen is as I was spinning, this would make a cylinder. If I were to take a triangle, a right triangle, and revolve it around its axis, this axis right here, it would make a cone. with a radius that's the length of the base. And again, this would be the radius of this cylinder. Okay. Another thing I could rotate is a half circle, and if I rotated a half circle, I'd get a sphere. Okay. So that's revolutions and cross sections. So revolution is just spinning a two-dimensional shape around an axis to make a 3D shape. Okay? And a cross section is taking a slice of a 3D shape and making a 2D shape. Okay? This is a kind of a double note stay. I'm sorry for the length. Our objective is to convert degrees to radians and determine the area of a sector, okay, of a circle. Okay, so the first thing we need to know is that there are 360 degrees in a circle. And the next thing that we need to know is a radian is another way of measuring how large a angle is. Okay, and we get this word radian from radius, and what it comes from is when we go back to that unit circle. Remember how we made like a circle with a radius of 1? Okay. If I wanted to know the diameter of the circle, I double the radius. And if I wanted to know the circumference, I'd do pi d. So the circumference of this basic circle is 2 pi. Okay. And I know all circles are similar to this unit circle with a radius of 1 because all circles can be dilated from this one circle, either made smaller or larger. It's still the same shape, just the length changes. Okay, so I'm going to use this circle as a reference. I know that the diameter is 2 pi. So if I know there's 360 degrees, I know that if I go 360 degrees around the circle, I've traveled a length of 2 pi. So what mathematicians started to do is they said, well, 360 doesn't really make a whole lot of sense. It's kind of an arbitrary number. 2 pi would make more sense to measure an angle because an angle is just some distance around the circle. So they said that 2 pi radians is equal to 360 degrees. And they said, well, if I go halfway around the circle, that's 180 degrees, and that would be just pi radians, or 1 pi radians. Okay, so what they're doing is they're converting degrees to radians for anything. So there is a simple formula for this, and it comes from using the proportion that 1 pi is the same as 180 degrees. So pi over 180 equals radians over degrees. So I can say there are 2 analogous formulas from this. One, that radians equals degrees times pi over 180, and degrees equals radians times 180 divided by pi. And we can convert back and forth using these 2 formulas. But if you forget these formulas, all you have to remember is that pi radians is equal to 180 degrees. Okay, and 1 pi would be just 180 degrees halfway around the circle. Okay, so for example, if I wanted to convert 45 degrees to radians, I'd say that pi over 180 equals x radians over 45 degrees. When I cross multiply, I get 45 pi over 180 equals x radians. And that reduces to 1/4 pi radians. Okay, and if I wanted to convert, let's say, 1/3 pi radians to degrees, I would do pi over 180 equals 1/3 pi over x. Now, since pi is on top in both of these, it'd cancel out, but I just want to make sure I work through slowly so you guys can see. When I cross multiply, I get pi times x equals 180 times pi over 3. These cancel. Pi x equals 60 pi. Divide both sides by pi. X is 60 degrees. So 60 degrees is equal to 1/3 pi radians. Okay? And 1/3 pi, 60 degrees, that is 1/6 of the way around the circle, because the circle is 2 pi. So how does this help us? Well, on the Regents exam, you're going to be given a circle and an angle in the circle. They might tell you that that angle is pi over 4 radians. And they will tell you that the radius, remember radius and radians are different, okay, that the radius is 10. They'll ask you, what is the area of the shaded space, or the shaded area? So to do this, I know my radius is 10. Here's my center. I'm going to find the area of the whole thing. So the area is 100 pi. Now, I want to find what the shaded area is. And the shaded area, well, I know the whole space, the whole way around is 2 pi. I'm taking out 1/4 pi. So I can find out how big this space is and subtract it from my total area. So 1/4 pi of this space, well, pi over 4, that's my angle, over the whole circle, that's 2 pi radians. That's the whole circle around. Remember, going back, we said 2 pi radians is the same as 360 degrees. It's equal to x, what I'm trying to find, over the whole area of the whole circle, 100 pi. So 1/4 pi over 2 pi is really 1/8. When I cross multiply, I get 8x equals 100 pi. I divide both sides by 8. I get x is 12.5 pi. So that would be the unshaded area. And that makes sense because the unshaded area is not even close to all of the circle. So to find the shaded area, I do 100 pi minus 12.5 pi, and that would give me 87.5 pi. I could do this if they gave it to me in degrees as well. So let's say they told me this was a 90-degree angle, and still the radius is 10. So what's the area of the shaded area? I first find the area of the whole circle. I know that area is 100 pi. Now I'm going to find the area of the unshaded region. Okay, so I do the angle over the whole. So my angle is 90 degrees of the unshaded area. The whole is 360. The unshaded part that I'm trying to find, I'm going to call x. And the whole area is 100. So same process as before, but now I'm using degrees. So again, I'm going to cross multiply, and this is where things get kind of yucky. Okay, so I'm going to divide both sides by 360. Okay, and now I'm going to simplify that. And I get 25 pi. So that's the unshaded area. To find the shaded area, I do 100 pi minus 25 pi, and that's 75 pi for my shaded area. So I found the unshaded area, then I subtracted it from the whole to find the shaded area. I could also do this where I figure out what angle measure this exterior angle is. So 360 minus 90 is 270, and put 270 here instead. And when I solve this, I'd end up with 75 pi, x equals 75 pi, and just jump right to finding the shaded area. You can do it either way, whatever works for you.